Venn diagrams are standard of excellence questions. And the catch here is that when I use intersection, I'm going to get a smaller area, correct? So this is B and C and A. So I have to do B and C first. Just showing you. Don't do this, just paying attention. I need B and C, which is the eyeball. But then I only want A. So I have to erase this. So is this going to be the answer? No. So A is out. B, I want B and A. So B and A is this. And I want C only. So it has to be in C as well. So it's that piece. Is that the right answer? No. This one I want B or C. B or C is the snowman. I want B or C. And I want where B or C overlaps with A. That's what that says, right? That and is intersection. So I want where B and C, B or C, the snowman, intersects with A. So it has to be in B or C and in A. So I need to erase all of the B or C that isn't in A. So A is this circle, right? Which is what's shaded, correct? So let's see. Yeah. All right. 3 has, whoa, an aggressive movement is what 3 has. Okay, the Venn diagram below shows 4 colors that are created by mixing the 3 primary colors, red, blue, and red, yellow, and blue. How many of the 7 colors are contained in A or B? So I need the A or B snowman. So this is A or B, correct? And I want where it intersects with C. So I can only keep the A or B snowman where C exists, yes? So I kick all of this out. Anything that's not in C. So what colors are left behind? Orange, black, purple, which is, oops, didn't mean to forget the highlighter. 3. Which is B. Okay, we're getting how many 4-letter arrangements? Oh, wait, the test tomorrow. Are you allowed a book? No, it's closed book, correct? Don't be like, Mrs. Lepp, I thought I could use minute. You cannot. Because it's a closed book, it would then be called harder than an open book. Are the questions actually harder? No, you just can't look back into your notes. So essentially, you could call it harder, correct? It is not harder. It is the exact same as the other tests. You just don't get your notes access. So if you did better on a closed book, it can replace your open book tests because technically it is harder because you don't have your notes to look at, right? You either know it or you don't. So it can replace the first 2. So here we have 4-letter arrangements. Whenever it's a word and I have 4 letters, I have 4 blanks. We agree? Whenever I get a word, what's the first thing I told you should do? Rewrite it and see if there's any doubling or tripling letters, right? So C, H, E, M, I, S, T, or what? Wait a second, there's nothing. I just rewrote the word. If I rewrite chemistry, that means I have no denominator, correct? Now it's 4-letter arrangements. How many letters are in chemistry? 9. Then do I do 9, 9, 9, 9? No, because words are like Scrabble tiles. I have 9 Scrabble tiles, correct? So you box and hold O with words. So if I kept a C here, then I would have what? 8. Say I keep an H here, then I would have what? 7. Say I keep a Y here, then I would have 6, right? 9876, how can I represent that with a P? Do you remember? 9 is the number I start off with. Has to go down by 1 each time, correct? P is how much, and then what do we put? How many blanks? 4. So those are the same answer, which is A, B, C, or D? B. Okay, then we're going to flip over. Sets P, F, and L are represented as the following. As follows. Set P are the capital cities of Canadian provinces: Victoria, Edmonton, Regina, Winnipeg, Toronto, Quebec City, Halifax, Charlottetown, St. John's, and Fredericton. Set F is Canadian cities with CFL teams: Vancouver, Edmonton, Calgary, Regina, Winnipeg, Toronto, Hamilton, Ottawa, Montreal. Set L are large cities, large central Canadian cities: London, Hamilton, Toronto, Ottawa, Montreal, Quebec City. What are the cities found in P and F, but not L? You see how it says that? P and F, but not L. So first off, I'm going to find the ones in P and F. So what's in P and in F? Looks like Edmonton, Regina, Winnipeg, Toronto, and that's it, right? So currently, without the and not L, I have Edmonton, Regina, Winnipeg, Toronto. Correct? But now I need to find the ones of those 4, how many are not in L? So is Edmonton in L? Is Edmonton in L? No, so Edmonton still exists. What about Regina? Is it in L? Large central Canadian city? No. Winnipeg? Nope. And how about Toronto? It is. So these 3 are the only ones in P and F, but not in L, which is B. Six. The archery club has 65 members, 25 of which are girls. So we have 25 girls, which means we have 40 boys. We have 65 total, because sometimes it doesn't even talk about anything other than just they need to have this many people. We need a 12-person committee, so no matter what, I need 12 people in some form. If I just needed a 12-person committee, I would go 65C12, correct? But we have to keep reading because there's more. It's to be created to determine ways to get more girls to join the club. What is the best representation for determining the correct number of ways the committee could be created if the committee must include exactly 8 girls? So is it just 8 girls in general? Or I need to have 8 girls and what? I need 12 people. 8 girls. And or? And 4 boys, because if I add that up, that's 12 people. We agree? And means I multiply. I'm at a 50-50 at this point if I just know that and means multiply. Correct? Are there any jobs here? Are we choosing boys from boys, girls from girls? Middle to middle, defense to defense, forwards to forwards, presidents from presidents, vice presidents from vice presidents, drivers from drivers, irons from irons. Whenever we do that, we use a what? A combination, a C, right? We're doing girls from girls, boys from boys, so it's a C, so it's D, even if I lost any other information. As long as I know if it's boys from boys, girls from girls, and an and, it's D. Okay? So girls, there are 25, C8, and 40, C4. Which matches D. But in this one, you could have just used reasoning of ands and ors to even knock yourself down to 50-50. Right? Bank accounts require a 4-digit personal identification number PIN. Our pins, when you go up to something and you press your PIN, does the order in which you press your PIN matter? Like if my PIN number is 4321 and I type in 1234, am I getting any money? No. So we know order matters. And if order matters, what is it? Permutation. So we know that this is out. So to access the automatic bank machine, the digits must make up a PIN, can be repeated. If you know how many PIN numbers there are to choose from, would you use a permutation or combination? Permutation, why? The digits, the order of the digits matter, or the order of the digits don't matter? Matter. So it's A. Then we have 8. 4 identical green buttons. The moment I see something like that, I treat it like it's a word. I've told you this over and over and over. The word identical, correct? So there's 4 identical green buttons. So I have GG, GG. I have 4 identical blue buttons. B, 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 B. Right? Identical means I have repetition. Repetition means I can't tell the difference. Can't tell the difference means I have factorials in my denominator. So you have to go look for the word identical or same model. So there's 4 identical blue. Quentin randomly chooses and removes 1 button at a time and places the buttons in a straight line. So if he's removing a button and placing it in a straight line, is he allowed to repeat? No. Taking out a button, placing it down. Taking out a button, placing it down. Taking out a button, placing it down. So I'm losing a button each time, right? The total. How many ways can 8 buttons be arranged? Would it be 8, 8, 8, 8, 8, 8, 8, 8, 8? No. What would it be? I have 8 buttons. I choose when I set it down. 7, choose when I set it down. 6, 5, 4, 3, 2, 1. What do I have to remember to have? Multiplication dots to show that it's not just a really large number. And I actually don't normally, come on board, I normally don't do the top until I've actually put 4 factorial in the bottom to represent the 4 G's and the 4 B's that looked exactly the same. Now, what if they weren't identical? What if it was 4 green buttons that you could tell the difference between and 4 blue buttons that you could tell the difference in between? How would this change? You just wouldn't have the division. That's it. So when you have repetition, you have to have a bottom, a denominator. A, B, C, or D? At the fair, you have a choice of 7 rides and 4 games. 7 rides, 4 games. How many different compositions of activities can you make if you will do exactly 6 activities? So I know I need to do 6 activities, no matter what, for every case. And I need at most 2 games. At most or at least means numerous cases, correct? We get more cases. It also means it's a standard of excellence question, which often means it's harder. We practice them enough that by the time a diploma comes, people don't feel their standard of excellency because you just have done them enough that you can do them. So we need at most 2 games. If I went to a store and I needed at most $2, what would I need? $2 or less. So $2, $1, or the case that everyone forgets? 0. That'd be the best store ever. You can go in and pay nothing and get stuff. Okay? So I would need at most 2 games. So I would need 2 games. This is my case 1. Or 1 game. Or 0 games. Why am I drawing a line here aggressively long? Why am I drawing an aggressively long line after each one? Yeah? You need 6 activities for every case, right? The first case has 2, the second one has 1, and the last case actually has no activities. We haven't done anything. We have no games. That's all we know. So we need to supplement with the other pieces. So there's games and rides. So the first case could have 2 games and 4 rides. And why do I say and? Because I need 6 activities. If I have 2 games or 4 rides, I have 2 games or 2 activities or 4 activities, right? I need to multiply. So you multiply within a case, but cases are added. Okay, so these are multiplied to get me 6 activities, but then my case is an or. So I have this one or this one. So every case is added to the next case. This one is 1 game and 5 rides, or 0 games and 6 rides. So I have to say the 0 games. No, I wouldn't actually even have to do that. Could I go 4 choose 0? Yes. Now I'm doing games from games, rides from rides, permutation or combination. P or C? C. Games from games, rides from rides, teachers from teachers, students from students, girls from girls, boys from boys, drivers, irons, irons, right? Whenever you're choosing from that exact same group of people, it's a C. So I have 2 games. I'm going to go 4C2, and means I multiply. 7 rides, choose 4. Or I start over again. 4 games, choose 1. 7 rides, choose 5. Or I start all over again. 7 rides, choose 6. And when you do that, what do you get? 301. And you can type it in all at once without even brackets because your calculators will always do BEDMAS. So they'll do the multiplications first and then add the cases. Okay. Number 10, the universal set of natural numbers less than 15. Universal is the natural numbers less than 15. So what's the natural numbers? What do you naturally start counting as a child? 1. Whole numbers, what are they? 0 plus the natural numbers, correct? Because it's a number with a whole. So natural numbers, 1, 2, do I include 15? Why? It says less. Bless you. P are all the prime numbers. What's my first prime number? 2. It's my first even, or it's my only even, and it's my first prime. Is 1 prime? No, 1 is neither prime nor composite. It just hangs out in neither prime or composite world. So I have 2, then 3. Prime numbers are factors of 1 and themselves, so 1 can't be because it needs to have 2 factors, and 1 only has 1. So 2, 3, 5, 7, 11, 13. O are the odd numbers, so it's going to be 1, 3, 5, 7, 9, 11, 13. And E are the even numbers, so it's complete composite or opposite of O. 2, 4, 6, 8, 10, 12, 14. Okay. Disjoint. What does disjoint mean? They don't share anything in common. So if I do the intersection of them, what am I going to get as my answer? Empty set. So which don't have anything in common? O and E will equal the empty set. Could we always do complements as well? Make sure you're not on your phones, guys. I'm reviewing you testimony. So could your complements result in an empty set? Like what about P and not P? They would have nothing in common, correct? Because P and not P are opposites, complements of each other. So you have to determine the disjoint sets. You can pick one. Explain why. Because the intersection of the 2 sets results in the empty set. As they have no elements in common. Okay. Define subset. What is a subset? Yeah. Yeah. Yeah, so everything in the one set is found in the second set, right? So define subsets and give an example using the sets above. Well, all of these sets are a subset of what? The universal set. So for example, P is a subset of the universal set. O is a subset of the universal set. E is a subset of the universal set. All elements in the first set are contained in the second set. Did someone just girl? Girl. The number of elements is literally how many there are, and it's because if there's more than 1 or 2 or 3 or 4, you'd actually have to ask that, right? Because you can't put it in a numeric response box. Numeric responses cannot be negative, and they have to be 4 or less digits. The other way I can ask it, remember, is like that. So I want the number of elements in O and P. So I'm going to list the ones in our P complement. So O is 1, 3, 5, 7, 9, 13, 11, 13. P prime is 1, not 2, 3, 4, 6, 8, 9, 10, 12, 14, right? And O is 1, 3, 5, 7, 9, 11, 13. This means what? And. It also means what other word? Eyeball on a Venn diagram. It also means what other word on our formula sheet? Intersection, right? So they can use the symbol, or they can say the word intersection, which would mean the same thing. And then or is union. So they could say union as well instead of using the other thing. So we want what's in O and P, or the intersection of both. So that would be 1, 9. Is that it? So it would be 1 and 9. And so some people go 1 and 9. But is that what I asked you? No, I asked for the number of elements. How many is that? 2. So O and P would equal 1 and 9 in squiggly brackets. N of O and complement of P would be 2. You see the difference between the two questions being asked? O and P naught is 1 and 9, because it's actually asking for the elements are. And then little n in front is how many there are, which is what they actually asked us. Okay? Then we're going to flip over. In the Venn diagram shown below, what are the elements in A and B? A and B in this Venn diagram is what shape? What shape is A and B? The eyeball. So A and B is the eyeball. So what are the elements? Chef salad and pizza. See, that easy. You keep changing the letter one and down. It's going downhill, hey? A group of 70 travelers are traveling to France. 40 of the travelers want to see. So there's 70 traveling to France. So that's my total. 40 want to see the Eiffel Tower. 35 want to go to a French bakery. 3 do not want either of these options. How many travelers want to see the Eiffel Tower only? So I gave you the singles and the not. What can I do to get the and? We've talked about this, right? We've talked about this. We see how many extra tickets there are. So we can just add those 3 up if we want. We said, okay, 40 put in tickets that they want to go to the Eiffel Tower. 35 put in tickets that they want to go to the French bakery. So some of those people would have put in both, right? An E and an F. Yes? And then the neither, there were 3 who were like, I'm a loser and I don't want to do anything. Do not. Actually, let's go loser. They're just losers. I don't know how much, like the Eiffel Tower looks pretty. I'm not sure if I want to really go to it. But the French bakery, hello. You mean a croissant? Maybe a macaron? Or maybe anything else? Thank you very much. French are known for their baking. All right, and then these people are like, no. Leave me in the hotel room. Okay, if we add these all up, we get 78. How many people were traveling? 70. How many tickets got put in? 78. So how many overlapped? 8. So we have Eiffel Tower. French. Can we short form on a Venn diagram? Only if you have a key on the side. Check it. So I can. So I have 8 in the middle. How many in the Eiffel Tower only? 32. 3 on the outside. How many in the French bakery only? These should add up to what? 70. Then you know you're right. Correct? The question is, how many travelers want to see the Eiffel Tower only? 32. Remember, if you're ever given only, you don't have to subtract. You can go right in and put that answer in every single time. Okay, we have a word with a lot of letters. Okay, A, accesses. A, C, C, E, S, S, E, S. And I'm like, cool, I don't even care what you're going to ask me. I'm going to put 2 factorial, 2 factorial, 3 factorial. So that I don't forget to do that. Correct? People are like, when do I not do that? Never. So always go do that right off the bat so you don't forget it. Okay? We want the vowels together. Accesses has 8 letters. So 1, 2, 3, 4, 5, 6, 7, 8. We want the vowels together. How many vowels are there? 3. We treat the vowels like they're different on the top, right? Because the bottom gets rid of the cases where they actually look the same. So how many vowels are there? There's 3. So I have 3, then 2, then 1. How many letters do I have left? I have 5, then 4, 3, 2, 1. If they said vowels together at the front, I'd be done, correct? They didn't say vowels together at the front. They said vowels together. So what do I need to multiply by? 6. It's always one more than the number after the hook together, because this counts as one case, 2, 3, 4, 5, 6, right? So I multiply by that, 6. So I get 3 factorial, 6 factorial over 3. 2 factorial, 2 factorial, 3 factorial, and you can punch that in all at once. You have to make sure you have brackets if you don't use the fraction button. If they gave it as a multiple choice answer, they might actually cross this off and cross that off, and write it as 6 factorial over 2 factorial, 2 factorial, or 2 times 2, because 2 factorial is just 2, because it's 2 times 1, or 4, right? We can change it. Anyways, how many is that? 180. Voila. Let me flip over. Okay, in how many different ways can a family of 5 people, 2 parents, 3 children sit in a row if a parent must sit on each end of the row? 1, 2, 3, 4, 5. How many options do I have for this one? 2. I always have to do my restrictions first. How many do I have for this one? 2 again? 1. Why is it not 2? You have to pick a parent and stand them there. And now we only have 1 parent left for the end. And then how many in the middle? 3, 2, 1. And this is a good answer like this? This is the answer, 23,211. Is that my answer that I'm going for? No. What's the answer to this? 12. Is that the answer I'm going for? Yes. Okay. I'm going to get you guys to flip to your notes, please. To the rational notes I handed out. So, remember, non-permissible values happen when your denominator can't equal 0, correct? You do have them. When your denominator, I figured. When your denominator can't equal 0. So, do I care about the numerator if they're just asking me for non-permissible values? No. Can my numerator equal 0? Yes, we talked about this. 0 divided by something is 0. That's totally fine. It's our denominator that's a problem. So if I'm asking you for non-permissible values or restrictions, we don't have to worry about our numerator at all. So I really only care about the denominator. Can I GCF anything out of my denominator? A 2. So I take out a 2. 2m divided by 2 is m. Plus, what's 10 divided by 2? 5. And I know I did correctly if I distribute that back in and get what I have. Right? So if I go 2m plus 10, I get that back. Now I have a 2 in its own brackets and an m plus 5 in its own brackets. Do you see that? A 2 in its own brackets and an m plus 5 in its own brackets. So remember what we did is we took those separate brackets and we set them not equal to 0. So I say 2 can't equal 0. Is that just a true statement? Yes. Does that get me any non-permissible values? No. Non-permissible values come when you have a variable. We agree? Is 2 a variable? No, 2 just can't equal 0. That's true, but it doesn't get me any NPVs, so I don't really worry about that. But m plus 5, that bracket can't equal 0. Because if this bracket equals 0, what's 2 times 0? 2 times 0 is 0. So I have to make this m plus 5 can't equal 0 because 2 times 0 is 0. So I have to figure out, okay, what would I fill in for m that would make this bracket be 0? It would be negative 5. If you can't see that, you can just solve it. How do I get m by itself? Subtract 5 from both sides. And I get m can't equal negative 5. Remember I told you you can check it by plugging it back in and see if you get your denominator equal to 0, right? So if I want to check and see if I'm correct, I'm going to check that m can't equal negative 5. So let's see. If I plug it into my denominator, it should create a denominator of 0. We agree? Not the denominator I touched, my original denominator. So if I go 2m plus 10, I'm going to plug a negative 5 in there. 2 times negative 5 plus 10. What's 2 times negative 5? Negative 10 plus 10, and what does that equal? 0. So did I just prove that if I plug negative 5 into this denominator, I'm going to get 0? Yes, so therefore it's a problem. So that's good. M can't equal negative 5, because if I plug negative 5 back in, I'm going to get a denominator of 0, which is a problem. So you can check every single time. Plug that number back in separately by itself and see if you get a denominator of 0. If you don't, you did not get an NPV, you got something else that works. D, what could I do to the denominator of D? Can I take out a GCF? Can I take out a GCF, Lucy? Right. I can't take out a GCF because there's nothing that I can take out of x squared and 49. But x squared minus 49 is a difference of squares. I don't care about the numerator because I'm just doing NPVs. X squared minus 49. What's the square root of x squared? X. What's the square root of 49? 7. And what sign needs to be in the middle? An addition or subtraction for a difference of squares? Nope, difference of squares. Subtraction. Difference means subtraction. From little on your top, difference, subtraction, same thing. Okay? So a difference of squares is a difference, which is a minus sign, of two perfect squares. So if I take the square root of x squared, I get x. The square root of 49, I get 7. So the x has to go in the front because it's in the front of this difference of squares. So I get an x. The 7 has to be at the back. And then I need opposite signs, plus, minus. I could have went minus, plus. It doesn't matter. So that's just getting the denominator into form I can use, correct? Now, every time there's something bracketed, you're going to say that bracket can't equal 0. So I'm going to have x plus 7 can't equal 0. And my other one, which is x minus 7 can't equal 0. Because if this bracket turned into 0, 0 times x minus 7 is 0. If x minus 7 turns to 0, x plus 7 times 0 is 0. So like the denominator would fully cancel. So you have to take each factor and set them not equal to 0 and solve. So how do I get this x by itself? Minus 7, yeah. Subtract 7 from both sides. And I get x can't equal negative 7. Then what do I do to the other one? Add 7. So I get x can't equal 7. Now I personally want to check them. If I plug them into the denominator, how do I check it? If I plug them into the denominator of my original, it should equal 0. Yes? Because we're saying x can't equal negative 7 because it would make my denominator 0. And we're saying x can't equal positive 7 because it would make my denominator 0. So can I not check and see if it makes my denominator 0 to see if I'm right? By plugging it back into the original? The original denominator is x squared minus 49. So let's plug it in. So we get x squared. Well, we're checking negative 7. So negative 7 squared minus 49. I'm just plugging it into my denominator. What's negative 7 squared? Negative 7 times negative 7. What's negative 7 times negative 7? 49. What's 49 minus 49? 0. So I know I'm right. That's an NPV. Because it would make my denominator be 0. When I plugged it back in, it made my denominator be 0. So I know I'm right. Then I have to check 7. So I'm going to plug 7 back into my original denominator. My original denominator is x squared minus 49. It's right here. Not the one I touched, my original denominator. Yes? So now I'm plugging 7 into it. So I'm going to go 7 squared minus 49. 7 squared is 49 minus 49, which equals 0. So I know I'm right. These are my two non-permissible values. They will often write them together. They'll often write them as x can't equal plus or minus 7 and give you an answer like that. If you write them separately or you put them together, you're equally as correct. Just box them so you know that that's what your answer is. If you do the whole question and you don't box any answers, are you letting anyone know that you know what the answer is? No? You're letting everyone know that you got some math and you can do math. But unless you box your solutions, we don't know if you know what the heck a non-permissible value is or if you just can do math with stuff and things. Okay? So always box your solutions so they know that you know what a non-permissible value or restriction is. Okay. We're going to work on these together anyways. It says your term, but we're going to do it together. For A, do I care about, these ones say determine the non-permissible values or restrictions, same thing, right? Different word meaning same thing, non-permissible values, restrictions. It's just what the variable can't be, because if it was that, the denominator would be 0. In each of the following cases. So I have 2x minus 4 over negative 2x minus 4. Do I care about the numerator if all they're asking me for is non-permissible values? No. The numerator could be a pig. It could be a smiley face. It could be a jungle gym. Like, it doesn't matter what that numerator is. When it says non-permissible values, I only care about the bottom. Okay? So, I look at the bottom and I say, can I take anything out? Can I reduce it in any way? So I always ask for GCFs first, then difference of squares, right? In 30-2, that's what we'll always do. Can I take anything out of it, GCF? I can take out a 2 or I can take out a negative 2, right? So I'm going to take out a negative 2. GCF, what operation are you doing when you're doing a GCF? You're dividing. So negative 2x divided by negative 2 is just x. What's negative 4 divided by negative 2? Positive 2. This negative 2 sitting out front, I put in its own brackets as well. Everything in a bracket gets set not equal to 0 after this. Because every bracket can't equal 0. Because the brackets are being multiplied together, right? And anything multiplied by 0 is 0. So I'm going to go negative 2 can't equal 0. Is that just a true statement? Is negative 2 not equal to 0? Yeah, true statement. Don't really care about it. Right? So when you have variables that you're going to get non-permissible values. So negative 2 can't equal 0. True statement. Great. Not helpful from the NPVs. Then I do my other one. X plus 2 can't equal 0. How do I get x by itself? Subtract 2 from both sides. So x can't equal negative 2. So now do I just box it and send it and hope for the best? You will check it. You will plug it back into your original denominator. You don't send it. You can check it. You plug it back to your original denominator and see if it equals what? 0. If it equals 0, you're right. So we're going to check it by plugging it back into the original, not something you've touched. So negative 2 times negative 2 minus 4. I'm plugging it back into the original. Did you leave it with them? Yeah. Perfect. What's negative 2 times negative 2? 4 minus 4. What's 4 minus 4? So am I right? Yeah. If I plug negative 2 into that question, I'm going to get a 0 in my denominator, which I'm not allowed. Okay? So I'm going to look at B. What can I do to the denominator in B? Can I take out a greatest common factor? Do I care that the numerator is a -5? The numerator could be anything. Non-permissible values, I do not care. Can't GCF the denominator, but what can I do to the denominator? Difference of squares. I have a squared minus 81. It has to have a different sign, which it does. If it has an addition, there's absolutely nothing you can do to it. Square root of a squared is a. Square root of 81 is 9. So do I have a difference, a minus sign, of two perfect squares? Yes. If you take the square root of them and you don't get a decimal, you have two perfect squares. Okay? So a difference of squares gets you an a in the front of each bracket and a 9 at the back of each bracket. And what signs go in between? Plus or minus. Could I go minus plus to prove a point that it doesn't matter? Yes. They just have to be opposites. So now that I've gotten it into a reduced form, how do I get the non-permissible values? Take each of them and set them not equal to 0. So I get a minus 9 can't equal 0. And I get a plus 9 can't equal 0. How do I get this a minus 9 by itself? A. Add 9. So I get a can't equal 9. One answer. This one I'm going to subtract 9 from both sides. So a can't equal -9. So now I just send it. I box it and send it and hope for the best. Do I do that? Do I just send it and hope for the best? No, I can check it. How do I check it? Plug it back into the denominator of the original, and if it creates 0, I'm good. Because it can't have it equal 0, so I'm saying a can't equal 9, because if it was 9, it would be 0. So I plug it back into the original. The original is a squared minus 81. So I have to put it in brackets whenever I substitute it. So I get 9 squared minus 81, which is 81 minus 81, which is 0. So I know I'm good, correct? So this is my check. Then I'm going to check this one. Remember to put it in brackets. So I get -9 squared minus 81. If you don't put -9 squared in brackets, your calculator will tell you it's -81, which is not true. -9 squared is the same as saying -9 times -9. We agree? -9 times -9 is positive 81. No matter what your calculator says to you. If you go -9 squared, your calculator thinks you're doing -9 squared in brackets, which is not what you want. So -9 squared is 81 minus 81, which equals 0. So I know I'm right. So both those answers are good. And they sometimes, like I said, put them together. A can't equal plus or minus 9. When the denominator is a perfect square. The difference of squares. You guys try C. There's a GCF you can take out. So this denominator, what could I take out? A P. It's not a difference of squares, because the square root of P is root P. That's not a difference of squares. I can take a P out. 4P squared, take out a P, I'm left with 4P. What's negative P divided by P? -1. So these are actually your two brackets. That one is not a difference of squares, because that's a single P. The variable needs to be squared in order for it to be a difference of squares, right? So I can only take out a P. So we do them separately. We say P can't equal 0. That one is done. It's the greatest thing ever if it's just a P by itself. And then we have 4P minus 1 can't equal 0. You have to do reverse BEDMAS when you're trying to isolate a variable. So instead of subtracting 1, we're going to add 1 to both. We do additions and subtractions first. And so now we have 4P equals 1. And then I can divide by 4. P can't equal 1/4. Then do we send it? No, you got to check it. So if I check 0, I always check it back into the original. So I'm going to check it. I'm going to get 4 times 0 squared minus 0. 4 times 0 squared is 0 minus 0, which is 0. So I know that that one is true. P can't equal 0. Do you agree? And I have to check a quarter. And if you got different answers, guys, and you chose not to check it, then you're not going to catch your oopsie. If you thought that was a difference of squares and you put 2p plus 1 or 2p minus 1 or something weird like that, when you plug them back in, you wouldn't get a 0. So that would be a hint that you oopsied. Right? If I plug a quarter back in, I'm going to get 4 times 1/4 squared minus a quarter. 1/4 squared is 1/16. 1/16 times 4 is 1/4. You could just type this into your calculator. It gives you 1/4 minus 1/4, which is 0. So I know I'm right. And they, like I said, we'll put them together, so they'll go P can't equal 0 and a quarter with a comma. I'm going to have you scroll ahead just for a sec to this simplifying. I want you, we're going to do simplifications here too, so you're going to have to leave space. But I do want you to try and do the NPVs for A and B. We're not worrying about simplifying for now. I just want the non-permissible values for A and B when you move ahead on page 6. A, B, C, D. Try the NP.